Hi everybody! We've got a great extension from today's STEM Pro Live where there's an entire curriculum available to any classrooms in Maricopa County at no cost. And this curriculum is made by the Maricopa County Air Quality Department. I'm here with Jenny Frank, the Education Outreach Coordinator for Maricopa County's Air Quality Department, to tell us more about that and what all is included in it. So Jenny, thanks for being here.
Thank you.
Tell us all about what's in this curriculum.
Well, we're really excited about our curriculum. I was a classroom teacher for 10 years, so I have a pretty good sense of what teachers need with a curriculum. So we have a unit that's written for grades kindergarten through second grade and one for third grade through fifth grade. So they're two separate units of about 6 lessons in each unit. Along with the lesson plans, which are aligned to state standards, include goals and objectives, as well as links to outside resources. We've also included some digital tools. Many teachers have interactive whiteboards or projectors. So I've created PowerPoints and then interactive whiteboard lessons that are on a flash drive that come with our unit. And then I also put together kits that have all of the materials a teacher would need to teach the hands-on inquiry-based lessons that are in the unit. So the idea is that teachers don't have to find it, they don't have to buy it, they don't have to make it. And best of all, we deliver it to them. So they don't even have to come downtown, trek downtown to the Air Quality Department. They can just give me a call, send me an email, and I will bring the materials to them. They check it out for a week to 2 weeks, and then at the end, after they finish teaching the lessons, I would come back and do a hands-on lesson with their kids on measuring silt levels in a sample of soil.
So thanks so much for being with us, Jenny, and we've got the information posted now if you want to access and learn more about bringing this curriculum into your classroom. Hey everybody, welcome to our very first broadcast of STEM Pro Live this school year. I am here with Ben Davis, who is the Air Monitoring Manager for Maricopa County, and he's going to tell us today about what the Air Quality Department for Maricopa County does, why it's important, and how he got to have his job here. So thank you, Ben, so much for being with us today. Tell us, how did you first get interested in science?
Well, actually, when I was probably about 7 or 8 years old, my father used to take me, would go out and sit out and watch the storms come in. I loved the weather. We would sit out on the porch, and my dad would sit out there, and I'd come running out, and the lightning would go off, and I'd get all afraid. I'd run back in. Then I'd come back in and try to sit with my dad. But I just really got a real feeling for the weather. I just enjoyed watching the storms and seeing all the different cloud formations and things like that.
Fantastic. And how did that lead into what you're doing today? What did you pursue in school and in college?
Well, it was interesting. Both my parents were engineers, so we had education was the biggest thing in our family. We actually were the only family that had a periodic table of elements on the side in our living room. So we had an education background. But again, what got me into science was something that I could understand, something that was familiar to me. And then I was going into engineering, and then I went into meteorology because that was the real passion. So I took what I really liked, and then I took I took what I knew, and then I took what I really liked, and I really became something I could really grab hold of.
Fantastic. And so what do you do here now as the Air Monitoring Manager for the county?
I'm in charge of the Air Monitoring Division, which is about 18 people, and generally what the the Air Monitoring Division does is answers one question only. What is the air quality like in Maricopa County? So when there's a high air pollution advisory day or stuff like that, those are my monitors that determine if the air quality is good or bad. So that's generally what we do.
Awesome. And why is that important? Why do we need to know what the air quality is?
Well, especially if you're susceptible, the very young or the very old are very susceptible to breathing and stuff like that. That affects your breathing and affects your ability to go out and to have fun on the playground or something like that. If you can't breathe very well, you can't go out and do your normal activities.
Awesome. And what things really affect air quality?
Generally, what we look at is what's called the criteria pollutants. We look at carbon monoxide, we look at nitrogen dioxide, sulfur dioxide, a lot of big words here. And we look at both lead, and we also look at particulates and ozone. Actually, that's the season we're in right now. And those are what they call the 6 criteria pollutants that the federal government has us monitor for.
And how are those things added into the air?
Well, it's not usually what they call comes out of traffic is our biggest thing. A lot of cars come out, carbon monoxide, stuff like that, nitrogen dioxide. A lot of particulates are. Everybody sees the giant haboob running through there. There's a lot of PM10. Some you see big diesel smoke, black smoke coming out of a big diesel truck, that's PM2.5 or smoke-related particulates. And then nitrogen and ozone. Unfortunately, ozone, you can't see it. You can only be affected by it, so it's not visible. But a lot of people see the big brown cloud layer in the wintertime. You can actually see those are the particulates, so you can actually see it.
Wow, okay. So now we're going to move on and show us how you monitor in the air, because like you said, you can't see ozone, so how do we know it's there?
Exactly.
So let's
so
see
generally what we
it
have
is.
here, we'll have a couple of particulate monitors, and that's what's really nice about these monitors is actually some are portable, some are stationary that gives you a higher, more accurate reading, but also you need sometimes to go out into the world and see what is the air quality like generally in my neighborhood. We can bring out portable monitors. Let's go this way. What's nice about this monitor, one, it's portable, but it's also, you can go back here, it runs off solar powered. So you can actually put it into solar banks, and so you can take it anywhere you want to. Generally what here is up here, the inlet comes up, that's where the air goes in, comes down through here, and it impacts onto this white tape. As you can see, this is where it starts, and this is how it ends up. So again, we have air comes through there, the machine will actually see what zero is, or it has what clean air is. And then after we have the air impact onto that filter, after a while, it'll actually come back and measure the amount of particulates on that filter. As you can see, if you put on there a lot, you can get a lot of darker for the carbon-based or burning, or if there's more of a brown, you can get more of the dust or the dirt mostly in the air on that.
And then again, so.
Oh, and generally then you have your temperature and your wind speed, wind direction, because what's nice about pollution for me is that's how I can relate my passion for weather with pollution, is because weather and pollution are very interactive with one another. If you want to go over here to the bigger one here, this is what they call, this is again, those two they measure the same thing, but one is more highly accurate than the other. Again, the same inlet, air comes through here. This is what they call a TEOM, which stands for TEOM, which is a tampered element oscillating microbalance. A lot of big words there on that. But generally what happens was they have a small weighing thing, because you're kind of weighing your particulates, and the air comes down, hits a filter in there. It impacts onto the filter. That filter increases its weight, and it's also vibrating. That's the oscillation. That change in oscillation actually works into a change of electronics, and that's why you look at mass concentrations here and how much particulates are being intake in the air. And again, so this is basically the intake comes down here, our oscillating microbalances down in here. This is the controller for it, the amount of air, and also get your electronic signal. Then we have this one connected to our data loggers. As you can see here is the amount of PM10, ambient temperature, pressure, and the different calibrations for the instrument. But again, and then this is stored up here. We have our wireless connection that allows us to take it to our data acquisition system, and then we put that data onto the website, so you can see it all within real time, as close as we can get it. This monitor will put out 5-minute data, so you can look at our website every 5 minutes. You'll get a new spot of data.
Very good. And remind us again, the PM10 on the monitor. What is that again?
That is the amount of particulates measuring 10 microns or less. A micron is, as they say, a human hair is about 80 microns wide. So chop that human hair into 80 spots, and 10. That's what's coming through the filter on here. That's what's going to go. That's going to bypass all the fences in your lungs and go into your bloodstream, and that's what affects your breathing. And that's what, when people are, especially who have asthma, have a really trouble breathing when they get affected like that.
Wow. And so, incredibly small. That's amazing. One hair is 80 microns
wide. That's wide. So you're going to chop that hair up into 80 chunks, and you're going to think that is just PM10. And even smoke is even smaller than that. So
because PM10 is like dust when we see a haboob coming.
And then PM2.5 is that smoke. If everybody has you've been around a fireplace and have the smoke hit you, that's PM2.5.
Awesome. So even smaller than what the dust is. Amazing. All right, we'll move on to the next machine. Just wanted to go over all that.
Generally here we'll go back to an older technology for particulate monitoring, but again, a whole lot more visual. Well, again, when you're measuring particulates, you're looking for a volume of a certain amount of air and how much particulates are in that volume of air over a 24-hour period. You can start off with a nice clean filter here, all nice and white. You run it through this machine here that'll suck air through it for 24 hours, and then you'll end it up like this. That's more of the carbon-based one, or the burning. And then you can have one more that's more brown. That's more of the PM10 or crustal from dirt. Now most people say, well, what does that mean? Well, imagine your lungs like this. 24 hours later, your lungs are like that. So that to me is, as I say, visually impacting of what that. We can also have a nice big display model of that too. We'll get to.
Awesome. And do have another question. All
Sure.
these machines have these little jars on them. What are those about?
Everybody asks that question. It's simply when you are measuring these things when you're measuring this amount of small stuff, you have to basically take out the amount of moisture in the air because you're actually weighing the water in the air. So water has to come out someplace, and this is what allows water to come out.
Awesome.
And that's where it collects.
Cool.
All the moisture comes in, it starts to collect here. All of them have that so they can collect the moisture away from it.
Perfect. All right. So we just saw that monitor that collected samples of smoke and dust and dirt in what had been those previously white filters. So here's a year's worth of collection of all those filters. So tell us what all's going on in these filters and why?
This generally what this is, again, its title is a seasonal approach to PM2.5 or smoke, especially when we do the burn, no burn days in the wintertime. This really shows you what's going on. Again, here, we'll start in the summer here, and you can see it's not that bad. Actually, when you can see, again, you start with this stuff in the summertime, particulate, especially for smoke or 2.5, is really on the low side, so you don't get a lot of that stuff.
Yeah, they're almost all white.
Almost white. But again, you go towards the winter, you can get clear, from a lighter, darker, 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 and even into here, where generally what happens is we can go here like Christmas Day on this. This is where everybody starts their fireplace, and a lot of people are burning things indoors and outdoors, so we get a lot of heavy stuff. So again, you start with the white, and this is actually an exceedance of the federal standards for health. It goes from this, and you can see the same thing happened to it last year up here. Again, from winter of 2009 to the winter of 2011, it shows you seasonally how the PM is affected over that time period.
So this dark area down here, you can tell, Christmas, New Year's,
Yep.
when a lot of schools are on winter vacation.
Exactly, and you can actually see,
home.
he said, does rain help? Actually, the one next to it here, it did rain that day. So when from a rainy day to non-rainy day where everybody was burning their fireplaces.
Yeah. And how does that rain help? That's just water just pushing.
The water clears out the air for you.
Yes,
Yes, that's why it's a nice clear and a nice clear crisp day after it rains.
Perfect. So we just looked at some of the particulates in the air, the smoke, the dust, the dirt. Now we're going to move into talking a little bit more about some things we can't see as easily with an actual visual filter like what we saw before. So now we're going to talk about ozone. So Ben, how does ozone affect us, and how do we measure that here?
What's different about these monitors is they'll actually measure the amount of a gas or an ozone monitor here, but we also have monitors for nitrogen dioxide and sulfur dioxide. Those are gases also. So what's interesting about these ones is that they actually have a tube that will come out to the back of them, and then we'll sample it, we'll draw air into the inside of the monitor here, and then it will tell us the amount of ozone in the air. Right now, this one's actually measuring 12.6 parts per billion, really low ozone. When we take it out there, we actually have high pollution days that you can measure the amount of ozone in the air with this type of monitor. What's interesting about this is these monitors take require calibration. We actually have to get a calibrator we can go out and make sure that this monitor is reading correctly. With monitoring, as they say, there's one thing worse than no data monitoring, that is bad data. We do not put out bad data because a lot of people use our data to make their life a little bit better or to cause other things to happen. So we have to produce very good data on that.
And talk to us again, how are ozone levels, how do they change, how are they affected, and what do they do to people?
What's interesting about ozone is it does not come directly out of your tailpipe like a lot of emissions. You do not measure ozone coming out of your car. Ozone is actually produced in the air from the stuff that does come out of your car. What they call volatile organic compounds and nitrates. Again, that's from stuff from burning, like gasoline, or if you ever seen somebody using a 2-cycle engine that's really smoky or something like that. Besides the particulates, there's those gas molecules that come out. Those go up into the air, they're hit by the ultraviolet radiation, especially in the summertime here. We got a lot of ultraviolet radiation, and the ozone started to produce. So ozone is never produced where the sources of it are. It's actually produced downwind of it. So that's why areas from central Phoenix, generally into the north and to the east, that's where we get our highest ozone. Why? It's not where the sources are, it's actually where the wind pushes the ozone.
Got it. And what does ozone do to people? Why do we
Well,
do
I
that?
always like to say ozone is actually a sanitizer. It will kill bacteria. When you see filtered water, they'll actually say it's used as an ozone generator. If they'll filter that kills the bacteria. Now put something that would kill bacteria. Now place that in your lungs. That's all he says. It starts to sanitize your lungs. That can irritate your lungs. That causes it to inflame. If you have already bronchial problems, and if they're already irritated and inflamed, you'll get worse and worse. So again, it hits the most sensitive people first. Then I can take a little bit more than somebody who already has asthma or something like that.
So now that you've seen a lot of the devices that the air quality department uses to monitor the air, we're going to look at what they do with all that data and how it's available to you. So Ben?
This is our air monitoring map. This is when we take our data that are nearly live data. It's down to 5 minutes. And when we put it so that people can understand air quality. Here you can see the green dots. This afternoon it's actually it's pretty green. Green air quality is relatively good. We have a yellow up here on our Humboldt Mountain. Again, we have, because remember with ozone, it actually travels in this direction. So you're going to have good air quality here, but the ozone's going to start rising up in the Northeast Valley generally on that. So again, it allows you can click on these things and you can see the different data sections in them and see what happened the hour before, or even actually the day or two prior to what was going on.
Awesome. Well, thanks, Ben, for showing us all around the facility and what you do with your job. Now we're going to open it up. Hopefully you've been thinking of some questions that you've been having as Ben's been speaking, and we're going to take our live questions and have you answer them now.
Sounds good to me.
Hey, everybody. Thanks again for joining us today for our very first STEM Pro Live of the year. Here I am again with Ben Davis, Air Monitoring Manager of Maricopa County Air Quality. We've got some great questions coming in, so now we're going to start asking those of Ben, and he's also got some really cool things to show you that he brought along with him today. And yeah, of course, keep those questions coming in. We'll get to as many as we can within our time frame today. All right, so first off, Ben, how long have you been working in air quality?
I've been working in air quality for about 17 years now. About 8 of those years have been with, I was a data person, where I took all the air quality data in and put it out so people could see it. And then for the last 9 years, I've been the air quality manager.
Very cool. We've got a few questions coming in about no burn days. So how many no burn days are there usually in Maricopa County?
Generally, there's about probably between 20 and 30 no burn days. Every year. Again, they vary over time. It's usually a very meteorological affected event. Usually those happen mostly during the winter time, like during the Christmas time when a lot of people use their fireplaces. So that's that's where most of the time you'll see them. But other times it will happen during the ozone season or stuff like that.
And how do we enforce those no burn days?
Well, that's usually not quite my division on that, but we do have what they call compliance officers or inspectors who go out and check to see if people are burning or not, or are burning during no burn days, and they will give you a violation on that. We have people who've gotten tickets before. But also, people can go to our website and file a complaint about people like that, and we'll also send out mailers to remind people that you're not supposed to be burning during these times of the year.
Great. And then a few questions about education to do with air quality. How do you educate the community to take this data seriously, to do their part to improve air quality?
Well, I think that's probably where our department now is looking very much into outreach, where we can explain a lot of the scientific data to people who are maybe don't have that background in it. And I think it showed the examples of, you can see examples of, the visual effects of air pollution, not just a digital number or something like that, where you can see how air quality actually affects you. I mean, that's been one of our challenges, to make sure we can explain all these types of things. And a related question from Luke from Banner Academy. What can we do personally to help with air quality in our area? Well, with a lot of things, there's on our website, there's a great list of things you can do, especially during ozone season, is fill up after dark. During the winter season, is fill up your vehicles after dark. You can make sure don't burn your fireplaces when there's no burn days are in effect. There's a great list of those types of things you can look at. It's also just conserving fuel. Don't burn as much. Make sure your lights are out so you don't use as much energy, which causes more pollution.
Awesome. And he's referencing the Air Quality Department's webpage, and we will be sending out, when we send out our follow-up email later today, along with a link to this broadcast that you can watch anytime after day. We'll also send a direct link to their website in there, so you can find all that data and find some resources. And the curriculum that you saw a little bit about earlier. So back to questions.
Sure.
An interesting one. How does humidity affect air quality?
Ooh, humidity. Generally, as you said, with our particulate monitors, we actually have to get humidity out of the air so we don't measure the amount of moisture in the air. Again, when you're measuring something in micrograms, you get a very, very small amount of weight. So humidity in the air can affect that measurement. Humidity can do two things, and actually makes it, if you ever go out when it's really hot and humid, the air is very still. The still air can actually cause higher ozone levels to increase because the pollution doesn't keep moving. So you can actually, that's one way humidity kind of keeps the atmosphere more still so pollution levels can go up.
And I think you touched on this a little bit earlier and just now talking about how air movement is pushing pollution to different areas. What areas are more affected by pollution in Arizona?
I get that question a lot. It's always interesting. It just literally depends on what kind of pollution you're looking at. Ozone is a transported pollutant. It's not really at the sources. Again, ozone does not come out of your car. Ozone is formed in the atmosphere from the stuff that does come out, the volatile organic compounds, the nitrates, the stuff that's the burning stuff that goes up into the atmosphere. The ultraviolet radiation hits that stuff and causes ozone to be formed. Ozone is usually downwind of these sources of that, so that's why generally to the north and east of the valley, that's where our highest ozone levels are. Where carbon monoxide particulates is more source oriented. If you're down by a traffic or areas of high particulates, you can get those are very source oriented around you.
Very good. And then talking about several of the machines you were talking about at your actual work site, and then we've got several more with you today. The question was, how did you build those machines? But I assume you didn't actually build them. That there's
no, we do. We do not. We actually work through our vendors on that to get these. They're also what they call EPA certified equipment. The vendors have to go through the federal government to make sure they get their certification because. There's lots of different machines that'll do particulates, ozone, and all that stuff, but you have to make sure that the is highly accurate. Depends on its accuracy, and that's also its price too.
Very good. And speaking of machines, do you want to talk about a few of the things you brought with you today?
Sure, we can if you like to.
Let's do that, and then we'll jump back into
The first one we have here is another particulate monitor here. This is what they call a dust track. It is actually, the machine part is right down here. This will measure PM10, PM2.5, and yes, even PM1, which again, those are the microns. PM10 being 10 microns, PM2 being 2.5 microns, and then PM1 being 1 micron. Again, human hair is 80 microns wide, so you can chop it up in 8 spots, and you'll get those 8 microns wide. So again, here's the inlet here for this. The air gets sucked into here, goes into our machine here. What's nice about this one, this is battery powered, so you can actually literally put it anywhere. And what's most interesting about this one is you can turn it on in 2 minutes, you'll have a reading, so you can tell what's going on instantaneously. Also, what's nice about with communication is we have our wireless internet connection here that allows the data to go up into the internet. We can access the data that way and also put out the data more easily.
Awesome. And this is something, because you have your stationary sites set across the county, this is something that if there's a particular
usually we'll do this at smoke events where you need instantaneous readings, you need to know what's going on right now. The problem with getting an hourly measurement is you have to wait an hour for it. This will give you within minutes, will give you a good solid reading.
Very cool. And did you want to jump into one other thing? And then
one of the things we do besides the network monitoring is we actually go out with our compliance officers. And you can, when they do inspections, like say at gasoline stations, we're making sure that the gasoline is a very big source of VOCs, and then you don't want that leaking out into the atmosphere. So they go out and inspect the gas station to see if it's not leaking. We take this meter with us right here. This is the multimeter, excuse me. It does things like oxygen, volatile organic compounds, and carbon monoxide. And what's nice about this, and if you ever see firemen actually have the same kind of instrument, but this is hand sanitizer right here, and it does have a VOC in it. Now you can see VOC, and it'll actually go off and measures too high, and that's what they call an LEL, which is the lower explosive limit. And alcohol is a very volatile compound, so it will actually catch on fire.
Wow, very cool. Thanks for bringing those in today.
No problem.
Several great more questions coming in.
Oh, sure.
A few questions about you. What was your degree in college?
My degree was a geography meteorology. I went through ASU.
Fantastic. And then what do you really like about your job?
What do I like? One, I like the variety in my job where I get to do things like work on data, which is always fun for me, looking on spreadsheets, but also going out into the field and during smoke, during fires, I get to interact with people like firemen. Also, I get to see how people are being directly affected, or how I can directly affect people. If I can show them what's going on and I can tell them about it, they can better change their life, or hey, they might want to leave during high smoke.
Fantastic. And we have a great question. How can kids get involved with air quality and taking care of the air in our area?
Well, that's always a good thing, because my 9-year-old daughter has always told me, Dad, let's recycle, Dad, let's do some things like that. So kids are always can get the grown-ups to make sure that they're doing their part too. But again, it's making sure you turn off your light at night so you don't waste electricity. Making sure that you don't have a fireplace burning during those high pollution advisory days. So there's some easily small things you can do. Again, one person can't do a lot, but if a lot of people do a little, then a lot happens.
Awesome. And an interesting question: are you involved with monitoring car emissions as well? Because that's something else that's required.
We do not do car emissions. We do what they call ambient air, which is basically the general air which people breathe. The state does do car emissions, so there are car emissions inventory. So it's more of a source, not just the ambient air.
Awesome. Let's see. Yeah, there's some great questions. I know we need to be winding down, though, because we know classroom time is precious and we want to respect that. Does elevation affect air quality at all?
Yes, some types of elevation does. Especially carbon monoxide and say like PM2.5, when it's really cold, that stuff will actually sink with the atmosphere. Cool air kind of goes to lower parts of the valley, so you can get higher concentrations in lower parts of the valley, where actually the opposite is for ozone. The heat actually pushes the ozone up hills and stuff like that.
Mm-hmm. Awesome. All right. Yeah, just
Lots
a few more we're going to get
to.
Does technology help with air quality? I'm not entirely sure.
Yes, technology does help with air quality. Mm-hmm. I mean, one, it'll allow us to measure air quality in a more realistic way, or in a quicker way. We used to do running air through filters. Remember, we had air through a filter, which actually was the old technology. Also, technology will help us, like I think it was the 90s catalytic converters will take the sulfur dioxide out of the air, so we don't have a lot of high particulates or high sulfur content in your fuel. Mm-hmm. Leaded versus unleaded fuel. When they develop new types of fuels, will allow pollution to cut down on that. There is airborne lead.
Awesome. And I'll ask one final question. I know there are a couple others on here we didn't get to, but hopefully you heard something that kind of tried to lump a few questions
They
together.
can always email me too on any more of the questions.
They can, and we can include a link to his email address in the email we send out later. What are some of the challenges you face in your job and that you have to overcome?
Ooh, challenges and overcome. Challenges I have is that the amount of data that we produce is very daunting. We'll do about 12 million points of data per year. So we have to make sure we're on top of the data. We're actually looking at the data every day, not just every day, but every couple of hours, and making sure that we have to do it. Plus, it's all about organization. The one thing in monitoring we don't want to put out is bad data. I mean, that's probably worse than no data, because people will actually say, oh, it's the air's good, but it's not actually. So we actually have to maintain it. It's basically, the challenge is to maintain the network, maintain all this stuff, so people can see what the air pollution is like.
Awesome. Well, thanks so much for being with us today. Students and teachers, thank you so much for being with us today. And remember, if you found what you heard today fascinating and are really excited to learn more, there is a free curriculum available to you. It comes with a variety of resources, tools that are used within the activities that the curriculum describes. And you can find that by visiting the link that we'll send out in the email after this. And yeah, thank you so much for joining us today, and watch for more information about our next STEM Pro Live.